Hey guys, this lesson is on polar coordinates. If you are in pre-cal, this is from 6.3, and if you are from trig, this is from 7.3. Alright, so the first thing we're going to talk about is what is a polar coordinate. The best example that I always give is if you've seen any movie where there's a submarine or a plane and you can see the sonar and the mapping. You see this circular image and that line that goes around as it beeps. So I've got an image for you here. You guys are used to rectangular coordinates, which is the x and y axis, very squared off. This here is what a polar coordinate graph and grid look like. So if you're drawing this by hand, you're going to start by drawing a T, and then you're going to do as many rings as you need. Each ring will represent a different distance going outward. And then you're going to continue to draw your unit circle. This is to measure how many degrees around the ring you want to look. All right. So for example, if you ever saw one of these movies, or maybe if you've ever gone boating, you saw that they designated a fish was in this spot. This would be out on the third ring and at 30 degrees. All right. So if we are going to plot, instead of giving you an x comma y, I'm going to be giving you an r comma theta. R will represent the ring, and theta will represent how many degrees you would turn. Okay, so I know this seems a little backwards, but anytime you're going to plot, I want you to start by finding theta first. If I give you a positive number, let's look down here at examples like 30 and 120, we're going to go just like the unit circle and go counterclockwise. So starting at 0, we would go up and over. If I were to give you a negative number, you can see down here this negative pi over 4, you would travel downward, just like the unit circle. Once you spotted which degrees they want you to look at, then you're going to look at r. So if r is a positive number, let's say positive 2, then you would travel 2 rings towards whatever degree we are looking at. If they gave me a negative r, well then I would just travel 2 degrees away from whatever degrees. So let's look at example A. This says 4, 30 degrees. Okay, so I'm going to start by looking at the degree, which is 30. I have 30 degrees right here. Okay. Once I spotted that line that I want to look at, now I see that r is 4, so I'm going to travel to the 4th ring out. 1, 2, 3, 4, and this is the intersection they want me to look at. And you know what? I'll even label that with an A. I'm going to jump over to C before we go into the radian measurements. So C says negative 2, 120 degrees. I would start out by looking at 120 degrees, which is right over here. And then it says to go negative 2 rings. So I always start here at the center. Instead of going 2 towards 120, we could see that this 120 degree line also lines up with this 300. So again, instead of going 2 towards, I'm going to go 2 away, and this spot right here would be, oops, I'm sorry, that's C. Okay, so that is A and C. Now you might be asking yourself, well, why didn't they just call this point ring 2 on 300? And you're correct, you could call letter C, let's say aka also known as, we could have called this positive 2, 300 degrees, because it is on the second ring pointing towards 300. These points could be labeled with different names. As I ask you here and in your book and in class, we'll play with those different versions, but in real life and as we proceed to the more complicated questions, I will always ask you to answer these questions like A is, in what's called the standard form, which is both the r and the theta being positive. So our AKA here is the standard naming for this point right here. Okay? Now, B and D are both asked in radians. So I've gone ahead and I've made a little graph with radians. You can label them both on your same drawing. So we're going to lay that down. Okay? So B says 3 and 3 pi over 4. Again, you're going to look at theta first, which is 3 pi over 4. I find it right here. And then I'm going to go 3 rings towards that radian. 1, 2, 3, and this one here is B. If you ever need help, you could always label these and make sure that it follows through to that ring. Okay? I would always suggest, if you're drawing this by hand, to never draw more than 4 or 5 rings. Let's say if I would have given you the number 20, you could always count by 5s and said 5, 10, 15, 20. So as long as you're labeling it accordingly, you'll be fine. All right, let's look at letter D. This is probably the trickiest one. I have a -1, comma, negative pi over 4. So again, let's start with our degree first. Negative pi over 4. So if I were talking about positive pi over 4, it would be the second one. But since it's negative, I'm going to go backwards down to this one. This right here is also known as negative pi over 4. Okay? And then, so I'm looking at this line right here. But because it says -1, instead of going towards that line where negative pi over 4 is, I'm going to go one back right here. And that's the intersection where I would label D. Feel free when you work on these problems to have your unit circle out, have one printed in radians, one in degrees, and then for each of them the positive and the negative version to help you out as you start. Alright guys, here's example 2. Before you watch the rest of this video, I encourage you to pause it and try these on your own, and then feel free to check them out. Alright, but let's get started on these. So first I'm going to ask you to plot these 4 and then label these 3 that I've drawn here, alright? So first plotting, we have 210. So 210 is right over here. So this is what I'm looking at, and then I'm going to go 4 towards it. So 1, 2, 3, 4, and this one is letter A. B says -2 comma pi, so I'm going to go towards pi. We know that pi is the same as 180. And then it says -2, so instead of going 2 towards it, I'm going to go 2 away, and here is where I'm going to draw B. So be careful not to get confused if some of these diagrams that are printed have these negative numbers. It's just generic. I like to, when I draw them out myself, to only write these numbers. Remember that, again, negatives is not left like we would see on an X and Y graph. It is away from the degree. Okay? C says -3 comma -300. Well, if positive 300 goes 3 of these, all the way around, I'm going to go the other way. So I'm going to go all the way to say 300 degrees. -300. So in my class, I have, I ignore these extra lines and I count. To get to 300 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 strings. So then I have them count 13 strings backwards. Okay? And so now it says, if this is -300, I want you to go 3 away backwards. So instead of going towards it, I'm going to go 3 away from my center. So I'm going to go 1, 2, 3, and this one is C. And the last one, I have 1 comma -3 pi over 2. So 3 pi over 2 is down here on the 270. So instead of going 3/4 of the way downward, going backwards would be 3/4 of the ways, and I end up here at 90. This is also negative 3 pi over 2. And it just says to go 1 towards that negative 3 pi over 2. So I'm going to go 1 ring here, which is this dot, and I'm going to draw a letter D. And I'm done plotting. Now let's label our star. Remember, when you are labeling, feel free to just use the standard version, both positive r and positive theta. Don't worry about going in the negative direction. So our star lands on 120, and it is on the 3rd ring. So that would be 3, 120 degrees. My heart is over here on the 2nd ring and on the line for 45 degrees. So it'd be 2, 45 degrees. And my smiley face is out here on the 4th ring, and it is on 315 degrees. So if you would have labeled these with radians, it would have been fine as well, as long as you are on the right line. Alright guys, so we have known for a while now rectangular form. We've seen the graph, we know x comma y. And now we just learned polar form, which is circular, and it is r comma theta. So we're going to start converting between the two. We'll start off by converting points, and later on in this lesson, we'll end up converting equations. Alright? So here are our two scenarios. We can go from polar to rectangular, so an r comma theta, the circular graph, to an x comma y with this formula right here. So what you're going to do is you're going to plug in the r and the theta here. So your number r times cosine of that theta will give you your x in your calculator. And then the same exact thing, but with sine in your calculator, will give you your y. It is very important that you stay consistent with your mode. If you are plugging in a degree, like 30 degrees, make sure your calculator is in degree. If you are plugging in a radian, like if this said 3 pi over 2, and that's what you're going to put here, make sure that your calculator is in radian. For this video, I personally will be working in degrees. Okay? So now, if we want to go the other way, from radians to polar, from rectangular to polar, here are the formulas we're going to use. So we would plug in the x and y here, square them in square root. You can plug that in your calculator and you'll get r. And for theta, you will do inverse tangent of the y divided by the x. Okay? Just a little side note, this formula up here will come out in the next 2 to 3 sections in this chapter. So this is a very important formula to feel comfortable with, okay? So now, example 3. Anytime you are converting a point, I do suggest that you plot it first and then convert it. This is extremely useful in letting you know what quadrant you're supposed to be in, and it'll narrow down your answer a lot. Okay? So, we have radical 3 comma negative 1. This is a rectangular, so this is an x and y that I want to convert to polar. So these are the formulas that I'm going to be using. This right here is my x, and this right here is my y. So I'm going to take the advice, and I'm going to plot it first. Maybe you don't know what radical 3 is off the top of your head. I sure don't. But I do know that it is a positive x value. So I'm going to be going to the right. And then my y is negative, so I'm going to be going down 1. So I will end up in quadrant 4. If you do use your calculator, you'll get I believe it's a 1 point something, and then negative 1. So it should be somewhere around there. Okay, so at least for now, I know that I am supposed to be in quadrant 4. All right, so now let's find my r. R is going to be the square root of my x value squared. So I have square root of 3 squared plus my y value, which is negative 1 squared. So a square and a square root cancel out. So here I'm left with just a 3 plus a negative 1 squared is positive 1. So I have square root of 4, which gives me 2. My r is 2. Okay? And now for theta, I'm going to say inverse tangent of my y value, negative 1, over my x value, which is radical 3. This one, if you're very confident with your unit circle, you can do this in your head. If not, feel free to plug this into your calculator. So I'm just going to type in, I'm in degree mode because I want to know what the degree value is. I'm going to do second tangent to get that inverse, and then alpha y equals to get that fraction, and I'm going to say negative 1 over square root of 3. Press enter, and I get negative 30 degrees. If you would like to stay consistent with keeping everything positive, remember, if 30 degrees was going up 1, negative 30 degrees would be going down 1. So the positive version of negative 30 is 330. Okay? If you are less of a visual learner and remember your rules a little better, remember last chapter we talked about coterminal. That was in chapter 4 for pre-cal and chapter 5 for trig. Coterminal will give you the positive value if you just, so this was the answer we got with our calculator, but if we add 360, then we get that 330. Okay? So the conversion, radical 3 comma negative 1 in rectangular, in polar would be 2 comma 330 degrees. And that would be our final answer for this question. All right, so here is another example. Now we're going to go in the other direction. We're going to convert the following polar coordinate to rectangular. So the point that I've given you is negative 2 comma 2 pi over 3. So as we work through this, I'm going to show you two variations using the unit circle and using your calculator. So again, our first step is going to be to plot this. This right here is my r, and this right here is my theta. Okay, so if I think about this, 2 pi over 3, I have a unit circle for you here. 2 pi over 3 is right up here in the second quadrant. Okay, so 2 pi over 3 will end up somewhere over here. And negative 2 means to go backwards. So if this is 2 pi over 3 and they want me to go 2 rings backwards, it's going to end up, let's say if there's a ring here. Whoa, that's a little off, but you get what I'm saying. So we know that we are again in quadrant 4. Okay? So now, step 1 is to find my x. X is equal to r, here my r is negative 2, times cosine of theta. Here theta is 2 pi over 3. Okay? And then we'll do the same for y, but with a sine. So, I always encourage my pre-cal students to use their unit circle. So if we look back here at 2 pi over 3, we have our cosine is negative 1/2 and our sine is radical 3 over 2. So this can become -2. This whole part right here becomes the cosine of 2 pi over 3, so it's -1/2. And now this one is -2 times the sine of 2 pi over 3 is radical 3 over 2. Okay? So now negative times negative is going to give me a positive, and half of 2 is just 1. And now here, a negative times a positive is going to give me a negative. And this is like saying 2 over 1. So these 2's are going to cancel, and I should just be left with negative radical 3. So in this problem, -2, comma 2 pi over 3 in rectangular has now become 1 comma negative radical 3 in rectangular. Sorry, this one's polar and this one is rectangular. If you feel more confident, and this is what I usually do with my trig classes with a calculator, you can just plug in this first line, -2 times cosine. I'm going to put a radian in, so I need to change my mode to radian. And now I can put 2 pi over 3. Press enter, and you can see that I still get that 1. And now I'm going to scroll up and do the same thing, but I'm going to put a sign there. And -1.7. How do I know if I'm right if here I have a negative radical 3? Well, these calculators do not convert to radicals, but you could always just put negative radical 3 and see what that gives you. And you can confirm that it's correct. All right. So that's my final answer for this question. And we are done with this one.